All right, we're going to go over the 3.2 Desmos activity, which is rational exponents. Remember, a rational number is anything that can be expressed as a fraction. So here you can kind of say how you're feeling today. Growth and decay rational exponents. Today's date is today. And your objective: define and apply rational exponents. Pretty much we're going to go in between rational exponents and radicals, and solve some simple ones. So you want to make sure that you have this in your notes, where you can go in between. So like, say I had 5 to the 1/3. That means my index is 3 and my base is 5. All right. Oops, and I see a little typo right here. There should be a P right there. So that's if your numerator is 1, because what's technically happening here is you have an exponent of 1. So let's say I had 5 to the 2/3. You really do it the same way. It's a little bit neater though. Your index is still 3. Your base is 5. And on this 2, you have a choice. You can put it on the inside of the radical, or you can put it on the outside of the radical. Either way is fine. So let's go ahead and simplify. So on this one, this will be the 4th root of 16. Well, and 16 is 2 times 2 times 2 times 2. So it's happening 4 times. So the 4th root of 16 is 2. That negative, we know how to deal with negative exponents. So it's really 1 over the 4th root of 16, which would be 1/2. All right, we're going to simplify a couple of these. Got workspace over here. If it's too hard to write with a mouse, do it on paper. So here, I'm going to have the cube root of 8, and I'm going to put the square on the outside. I could put it on the inside, but I think on this case it's easier to have it on the outside. Well, 8 is 2 times 2 times 2. So the cube root of 8 is 2, and it's still being squared. So the final answer is going to be 4. Well, on part D there, I just have a negative exponent, so that's just going to be 1 over 4. All right, on this one, we're going to solve. And you might want to write this down in your notes. When solving, you want to get the same base. So we know 8, or you should know that 8 is 2 to the 3rd. All right, and you might want to write all your 2's with exponents, maybe even some of your 3's with exponents, and have it like as a little cheat sheet in front of you, because it's going to make life a little bit easier if you don't know those off the top of your head. So I'm going to have 2 to the x equals 1 over 2 to the 3rd. Well, they're not quite the same base yet. I'm going to move that 2 to the 3rd up, and when it moves locations, it changes signs. So I'm going to have 2 to the negative 3. All right, this only works if bases are the same, which they are in this case. Your bases are 2. So I can say if the bases are the same, the exponents have to equal each other as well. So x is negative 3. Let's go ahead and do another one. On this one, though, I'm going to have to change both bases. And I know 9 is 3 squared. 27 is 3 cubed. So I'm going to use my workspace over here. So I'm going to have 3 squared. That's my 9. And I still have that x plus 1. And I'm going to kind of do a little work over here. I know that that is 3 cubed. And it doesn't say it, but it's a square root, which means my index is 2. I can rewrite that as a rational exponent, which would be 3 to the 3 halves. My index always is in the denominator. So that's going to be 3 to the 3 over 2. Well, now I've got the same base, so I can set the exponents equal to each other. 2 x plus 1 equals 3 over 2. Go ahead and distribute. I personally don't want to deal with that fraction, so I'm going to multiply everything by 2. Multiply this side by 2. Multiply this side by 2. And that's going to give me 4x plus 4 equals 3. Subtract the 4. And I'm going to divide by 4. Negative 1/4. Alright, on this one, I notice I have a coefficient in front of my x squared. It's actually going to be easier to deal with that coefficient. So I'm going to divide both sides by 4, and I'm going to be left with x to the 3 over 2 equals 8. Well, on this one, I want to get rid of the exponent here. I can't really get the same base because I have x here as my base. So I just have to remember my rules of exponents and a little bit about fractions. I know if I multiply anything times its reciprocal, it's 1. So the reciprocal of 3 over 2 is 2 over 3. So I'm going to raise both sides to the 2 over 3 power. And what happens? Those 3's cancel, those 2's cancel. I'm left with x to the 1 power, or just x. And that's going to be the cube root of 8 squared, which we have done that already. Cube root of 8 is 2. 2 squared is 4. Alright, we just solved that one. Alright. A house was bought 5 years ago, so your T is going to be 5. For $100,000. So that was the initial amount. And just sold. So your ending amount is $135,000. To the nearest tenth of a percent, what was the annual? So we're looking for R. Well, use your formula. A sub T equals A sub naught 1 plus R to the T. So I'm going to go ahead and plug everything in. I'm going to get 135,000 equals 100,000. Sorry for the handwriting. 1 plus r, and my t is 5. Well, again, I want to get the r by itself. I'm going to deal with that coefficient of 100,000, so I'm going to divide both sides by 100,000. Those cancel. Zeros cancel. 135 divided by 100 is going to give me 1.35. So I'm going to have 1 plus r to the 5th. Well, I need to get rid of that exponent right there. So I'm going to need to make sure I have my calculator ready. Because the way I'm going to get rid of that 5 is I'm going to raise that to its reciprocal, which is 1/5. Or you could have done the 5th root as well. Either way would have worked. So I can't do that in my head. So I'm going to use my scientific calculator, 1.35. And depending on your calculator, it might be y to the x or x to the y. And I got 1.0618 equals 1 plus r. Subtract 1 from both sides. And I got 0.0618. Well, I want that as a percentage, so I'm going to move it 2 decimal places. And it did say to the nearest tenth, so 6.2%. All right, there is a cart sort. I'm not going to go through that. I think you can handle that on your own. You can check your progress on the next screen, and then there's a second one for you to work on. And then at the end, kind of think about how well you understand this material, and does it make sense? Did you like it? And go from there. All right, enjoy.